Yeah, so my name is Adrian Mouat. My official title is Chief Scientist at a company called Container Solutions, and we basically do consulting around microservices, cloud native, etc. I did write a book on Docker, which is probably the main reason I get invited to give talks now and again. There's also a free Docker security book that you can download from O'Reilly that will cover a lot of the stuff that I'm going to go through in this. It is quite a Docker-focused talk, but there's a lot also in there about containers and microservices in general. If you want to reach me, the best way is probably to reach me on Twitter, where my handle's at Adrian Mouat. So in this talk, I'm going to start by talking a little bit about what security is and what the benefits of having security are. Then we'll talk about some specific attack vectors that are perhaps more relevant in containers. Then a philosophy about how you deal with security. I've got a short demo, which I was just working on, so it's got the potential to go horribly wrong, which I'm sure you all enjoy. Yeah, and then sort of the second half of the talk is just a whole bunch of various tips and techniques on how to secure a microservice-based system, especially a Docker one. Okay, so one of the funny things about security is you don't really get anything. If you think about a footballer, if a footballer does well, you can win medals, you can win the World Cup or something. You do security well, you don't get anything. Nobody gives you anything at all. And it's actually a bunch of things that don't happen that are the interesting thing. So you don't get any medals, but some interesting things don't happen. What doesn't happen is your site doesn't go down because somebody's managed to exploit some vulnerability. Your front page hopefully doesn't look like this because some script kiddies managed to get in and give your site a redesign. You probably don't start selling Viagra on the site, or at least I assume Tame Town Council in the UK didn't mean to start selling Viagra. And that's actually quite an interesting search, because all I did was search for government sites and buy Viagra. I assume if you run that search again today, you'll find a bunch of similar things, and it's all sites that have been hacked and are doing that. Also, you don't lose your customer's credit card details. Clearly, that's about almost the worst thing that can happen. And I think this is actually becoming more and more the norm, is that attackers will go after valuable assets, like customer details and so on. And you won't necessarily hear about it, but then years later it comes out in the news. There was also one a couple of years ago where, excuse me, where military and intelligence personnel, there was sort of details on them were leaked. And that was particularly bad, because it wasn't just details on them and their addresses, it was also their family. And these were people that could be targeted by foreign governments and criminal elements. So it put people directly, put their lives at risk. So that was a particularly bad one. The next section, it's just some things that I think you should be thinking about in particular when trying to protect a container-based system. So most of you are probably aware that with Docker especially, and basically all container formats, the way it works so quickly and effectively is that the kernel is shared between all the containers and the host itself. But that has a bunch of side effects. So for example, if one container was to cause a kernel panic, it would take down not just that container, but all the other containers on the host and the host itself. Similarly, if one container can use up all the memory, they can starve out other containers and result in a denial of service attack. Same goes for CPU and so on. If you can steal a CPU and starve out other containers, then you can potentially run a denial of service. Container breakouts. So this is just the idea that containers are relatively new technology in terms of Docker at least, and C groups and namespaces. And it's not really clear how secure things are yet. And so what are the chances of an attacker that gets into a container being able to break out of that container and access other containers or the host itself? So you should probably move on the assumption that it's unlikely but possible. Poisoned images. So Hands up here, like who uses image from the Docker Hub? It's going to be practically everybody, right? But how do you know what's in that image? Well, you pretty much don't. You're trusting a lot of things. You're trusting who built the image. In the case of the Docker official images, that's probably OK. But you're also trusting that nobody has tampered with it at rest, and you're also trusting that it's not been tampered with in transit. And there are a bunch of mitigations you can put into place to deal with the provenance of images, and I'll talk about that later, but it's definitely something to be aware of. And I should point out, all these things that I'm talking about here, they're not unique to containers. They also exist in the VM world, but perhaps the problems are more acute with containers. And that's particularly the case with secrets. So if you have a microservice architecture, you probably have dozens, possibly hundreds, of containers running and constantly being killed and recreated and moved and so on. And the issue is, how do you get your secrets, things like database passwords, API tokens into them? Because in the old VM world, you might just have had 2 or 3 VMs running, and you can just manually insert the secrets. No way you can do that with containers, because you've got so many things coming and going. You have to have an automated solution. And so doing that securely is obviously important. OK, so I guess this is the next bit. It's just 2 slides on security paradigms, and it's possibly the most important thing to think about. So the first one is this idea of defense in depth. And it's just the idea that you should not rely on any one thing for security. So some of you might remember, like basically back in the 90s, there was a lot of trust was placed into the idea of firewalls. And basically, a lot of companies felt if their firewall was there, they were secure. And the issue was, if an attacker got past the firewall, or perhaps already was on the inside, then everything was open. So there's just this one layer of security, and once you're past it, you basically had access to everything. And clearly, that's a bad idea. You want multiple levels of security, so if an attacker gets past one, there's further hurdles for them to get past before they have access to sensitive data. So things might be encrypted, you might be monitoring things for anonymous behavior, etc. You might even have intrusion detection systems, etc. It's just this idea of not relying on any one layer. And the analogies with a castle, so as well as having a moat around the castle, you've got a drawbridge, as well as a drawbridge, you've got thick stone walls. But also, if an attacker gets past the first line of security and gets through the main wall, there's still several other keeps inside that the attackers will have to fight their way through before they can get to the crown jewels. So just this idea of defense in depth, which is very close and links into the idea of least privilege. And this is the idea that a process, or in our case a container, should only have access to the data and functions, data and resources are essential to its function. So perhaps the easiest example is if my container does not need to access the database, it should not be able to access the database. I should not be able to open a network connection to the database container, for example. So you're just reducing the privileges of containers. This is based on the very old principle of least privilege, which was, I think, Jerome Salzer back in the 70s. But there's also a good talk by Nathan McCauley and Diego Monica, who are the security guys at Docker, and they give a talk called Least Privilege Microservices that you can find on YouTube if you want to hear more about that. OK, the quick demo. So I was playing with this. Apologies if it all goes horribly wrong. Is that big enough? Yeah, it's not too bad. So is it running at the minute? OK, so I've got, well, I'll take it down so you can see me run it. So I've got a very simple Node application that I'm going to run, if I get the syntax right. Good. So all it is a very simple application. It takes in YAML and prettifies it for you. So what it's meant to do is take something like this, button, and it prettifies it, highlights it, etc. So very simple application, built using Node. We've intentionally made it insecure to show a couple of points. The interesting thing is we go back, get back to the main page. but I also have this evil.yaml here. Oh, this is a problem. How? Use PB copy. And if we paste that in, then you see it looks a bit suspicious. And you can read it. Basically, there's some JavaScript in there. And when we click go back, it's overwritten the front page index.html and replaced our front page. So it's a very basic hack. It's come about because of a vulnerability in the YAML libraries that we're using. So it wasn't a run vulnerability, we just intentionally used a runnable version of the YAML library, which is something that could happen to you any day. So what should you do if you turn up in the morning and your front page looks like that? Any suggestions? No. Turn it off, I guess, is the immediate suggestion. Ideally, in the best case scenario, is you've already thought about this and what you would do if this happens. And you'll have a sort of guidelines, incident response handbook or something. Hands up if you have an incident response handbook. Come on, somebody must have it. Seriously? Normally it's like a few hands. Nobody has an incident response handbook. Okay, well that's something for you to all think about when you go back. Basically, all it is a set of guidelines over what to do if like a hack is discovered. You know, it might not be your front page looks like that, but you've discovered some behavior that should not be there, and you suspect somebody's got access to data or machines that they shouldn't. And it's just a set of guidelines telling you what steps to take. Because the issue is, if this happens, it's a very high-stress situation, and it's easy to panic and do something stupid. So if you have a set of guidelines, it just de-risks the situation. You follow the guidelines, and you can't go wrong, and you can't be blamed for anything. And what they should say, probably as your first step, is to isolate the compromised parts of your system. So if that's just a container, perhaps you can just disconnect that container. But it may well be they've got access to the VM as well, in which case you need to isolate the VM. So first things are move to establish what the extent of the compromise is and to isolate that part of the system. You can do that pretty simply. So this Docker network disconnect. If I get this right. Or do I not give it a name? Yeah. So what I'm saying here is disconnect the container Hungry Boar from the network. And hopefully, if I reload this, it can't be reached. So that's a very simple way of disconnecting something so the attacker doesn't have access. If they already got in somehow, it may still have access, but it's just an example. But what you don't want to do is you do not want to delete that container, because you need to analyze it and figure out how the hack occurred. Because if you just take things away and restart them, what's going to happen is the attacker can immediately compromise you again. So you have to be able to figure out how the hack occurred. So if you just disconnect it, the nice thing is you leave the processes running. So you can still have a look at Docker top or whatever and see what processes are running inside the container. If you stop it, it will stop the processes, but it won't delete the file system. So if you're not sure about running Docker network disconnect, you can run Docker stop. Which will take a few seconds. Yeah, and once that runs, the container will be stopped, so definitely nobody can access it. But I'll still be able to run Docker diff on the file system, because the file system for that container still exists in disk. So I can still run Docker diff. And what that will tell me is the differences in that container's file system to the image it was created from. So in this case, it's telling me this file has changed. Well, I should say created. But So it's basically showing me which files have been changed in this container until we can see that this file has been hacked. And there's a few other tools in Docker that can be useful for stuff like that. So the first thing you probably want to do is try and mitigate the situation. So one very simple way we can do that is that we restart the container, but this time I'm going to give exactly the same command, but I'm also going to pass read-only. And what that's going to do is it's going to tell it to use a read-only file system. So this time, when we attempt to run the hack again, so we should find our containers back. And if you paste in the hack code again, we just get an exception. And the reason for that is the JavaScript tried to write the file, but couldn't because it's a read-only file system, so an exception was thrown, which resulted in the invalid YAML message. It's not actually invalid YAML, it's not a correct message, it should be exception or something. But anyway, the point is, this is no longer vulnerable to the same attack. However, it is still a vulnerable container. You know, the attacker is still able to execute arbitrary JavaScript on our container, right? It's just that in this case, he couldn't write the file, so it cut out that particular attack. The only real solution is, well, either to turn the service off completely or to replace the vulnerable library with a non-vulnerable version. And there is actually quite a nice way you can find out if your Docker images are vulnerable to attacks like these. You can use something that's called an image scanner. So a few of you have possibly seen Docker security scanning. So if you go to the Docker Hub, hopefully I've got, and you look at the official images. Oh, I need to be logged in. Oh, it's not going to work. Sorry, but if you log in and you look at the official images, it'll show you a sort of security scan of the image, and it'll show you if it's got any vulnerabilities, and it'll list the exact vulnerabilities. And that's very nice, but the first thing you notice is all images have vulnerabilities, literally just about all of them. Even like CentOS, Debian, Ubuntu will have vulnerabilities. So naively, you think, well, I'm just not going to put my image to production if it has a vulnerability. But you can't do that because it will have vulnerabilities. So what you actually have to do is analyze each of the vulnerabilities and decide whether or not it affects you. Because a lot of the time, it's going to be in a piece of code that isn't touched by your application. So you're safe to run with it, or there may be some mitigation you can put into place. So unfortunately, it's not as rosy as it may seem. As well as Docker security scanning, there are some other solutions. There's a free open source one called Claire from CoreOS, which is quite nice, and you can take a look at. What I particularly like about it is it's API-driven, so you can easily embed it into like a continuous delivery system. There's also Pika from Macro Security, Twistlock, and Atomic Scan from Red Hat. So Claire and Atomic Scan, I think, are both free, but I believe both of them operate on the level of package list. So they're not all equal. Some operate on the level of package list, and some operate on the level of binaries. So Docker security scanning will actually go to the file system and take checksums of the files it finds and compare those against known vulnerabilities. However, Claire will just go to yum or apt and ask for a list of all the packages that are installed and compare those to known vulnerabilities. So the problem with using the package list approach is that you may not find, well, you won't find vulnerabilities in software that you've, like, say, downloaded from the curl command or software that you've built yourself, for example. But Docker security scanning and Pika may well find those vulnerabilities. There's also dependency checkers. So there's the OWASP dependency checker, which will check library dependencies and stuff like Node Security Project. So in the example I just showed you, there was a vulnerable Node library that did the YAML processing, and if you run the NSP program, that does find that vulnerabilities. These date back to before containers, so these are just command line utilities that you can run on your code. Okay, so the next part of my talk is basically just a whole bunch of tips and techniques. It's reasonably Docker specific, but it can certainly be generalized, a lot of it, to microservices and orchestration frameworks in general. Possibly the first and most important one. Quite often I get asked about the differences in security between VMs and containers. And a lot of people claim that VMs are a lot more secure because of the hypervisor layer. And there is an argument there. But the thing is, most people are going to be using VMs and containers together, right? You're going to run your containers inside VMs, most likely. And you can leverage that a bit further if you do things like put containers of different security levels on different hosts. So for example, if you've got a PHP front end and a JavaScript and a Java backend doing credit card processing, put all the containers that are doing a credit card processing on one group of hosts and completely separate from your PHP front end. And that way, if somebody breaks into the PHP front end, they've got another couple of hurdles to cross before they can get to your credit card details. Yeah? This also brings us onto Dirty Cow. Who's heard about Dirty Cow? A few of you. Okay, so this was a pretty recent vulnerability a couple of months ago, and it's found in a Linux kernel. And basically, it allows privilege escalation due to a race condition when writing to a file, I think. Interestingly, though, it can be used to break out of containers. And even if you have -- read-only set, you can still write to the file system, which is annoying to say the least. So the only way to mitigate this is to run a new kernel. So if you've not updated your kernel, you probably are vulnerable to this attack. So you can figure out your vulnerability by running this. You can actually try it on my laptop. I suspect, no, I just updated the kernel, so I think this should be safe. Yeah. But you can run that, and it'll either say you are safe or you are vulnerable. But the point is, this is basically a complete own, and it is a very worrying attack, and kind of proves the point that you may need to consider VMs to contain your containers and defend against things like this. If you want to read more about it, there's a couple of sites there. Similar to segregating by host, you can also segregate by network, and I'm talking about like the logical networks, not the hardware level, but the sort of Docker network create level. So what you can do is create different networks for different areas of your system. So your front end will exist in one network, and your back end in another network, and only the API that goes between the front end and the back end will sit in both networks. And that way, your front end containers will not be able to talk to your database containers, for example. They can only talk to the API that bridges the two networks. And it's pretty simple to do with stuff like Docker network create front end. Docker privileges equal root privileges. If you give somebody access to Docker, you have given them root access to that machine. You probably already realized that you can do docker run -v and mount whatever files you like. But if you're a bit sneakier, I mean, this is just interesting. It's not really an exploit because you just have to accept that if you can run Docker, you have root access. But if you run this piece of code, so I'm currently my user. If I run that code, what it'll do is it'll mount the current directory with this -v command. So that mounts the current directory as /data, and then runs a Debian container, copies /bin/sh executable to /data, sets it to be owned by root, and then sets a set UID bit. I'll talk a little bit more about set UID later. But basically, what that results in is this .sh, executable in my current directory. If I run that, and I can spell, and then root on my host. So this isn't in the container, this is on my host. I've suddenly got a root shell on my host, just by copying an executable out of a container. So I'm only making the point that if you give somebody Docker privileges, they have root access to your host. User namespacing. By default, you don't get user namespacing. So just to explain what namespacing is, it's just the idea inside a container, you get a different view of things. So if you run a container, you get your own file system that's separate to the file system on the host. you get your own IP address, so you get your own network stack that's separate to your host network stack, and you also get your own view of processes, but you do not get your own view of users, or more accurately, UIDs, because that's at the kernel level. What that means is if you're root in a container, that's the same user as root on the host. And the issue there is if a container breakout occurs and the root in the container, there will be root on the host. Basically, the most sensible thing is just not to run your applications, but to run in containers as root. You wouldn't do it in a VM, just don't do it in a container. Just set a user and run your application as a user. And that way, if they break out, there'll be an unprivileged user on the host. Also, quite simply, if they break into the container, they'll have less privileges inside the container. Docker did bring out user namespacing, and it started in 1.10. And basically, you can turn this on in the daemon, and what it will do is it will map users inside a container to high-numbered users on the host. So root in a container will now be like user ID 5,000 on the host. However, there are a few gotchas. The first thing is you set it in the daemon level, so you set it for all containers. And that's basically to do with the file permissions. So when you do a Docker pull, it has to set the file permissions for your mapped user. There's also a couple of other things. You're going to run into problems with volumes fairly obviously. And also volume plugins may not work with user namespacing. You can't use --PID equal to host or --net equal to host if you use user namespacing. And also, I think they might have fixed this, but certainly, it used to be the case that you couldn't use read-only file systems, which was annoying. And finally, there are some restrictions on certain operations, so you can't create device files, for example, if you turn on user namespacing. However, if you use user namespacing or not, I do suggest you set a user in your Docker file and run your applications as a user. It's pretty simple. You just need a bit of code like this, simple units command to create a user, and then you can use the Docker file command user to switch to that user. And that will take effect for all following Dockerfile statements and also when you start the container. If you need to do something at runtime in your container as root user, for example, set ownership permissions, what I suggest is you use a tool like GOTO or sudo. So you'll start up as root, do whatever you need to do as root, and then change to an unprivileged user using something like sudo or GOTO. Be careful when deleting data in Docker files. So, you can do this, but it doesn't work the way you think it works. So here we've got an example where somebody has curled some source code, they've untarred it and made it, and then they try to tidy it up after themselves by removing the tarball. But there's an issue here, because this won't actually save you any disk space. Each Dockerfile command results in an image layer. And so this file here has already been written to this image layer up here, and you can't get rid of it. OK, you can hide it in lower levels, but you're not saving any disk space. And you can still get to it if you know what you're doing. So what you can do is delete the file in the same layer or same instruction in which you create it. So if I just lump all those commands together, that will work. And that file will not exist inside the image. The reason this is important for security is because I actually answered a Stack Overflow question where a user had done this. They'd copied in their GitHub key, they downloaded the private repository, they built that repository, and then they'd removed the key, and they'd uploaded this image to Docker Hub. So that basically meant they'd given the whole world access to their GitHub key. They hadn't realized it, but they had. Yeah, so do not do that. Do not think you can delete credentials. They still exist in the image. We've seen this already, but a very useful command to easily increase security is to set the container file system read-only, just pass -- read-only, and you can't write to the file system, which cuts out quite a few attacks. People won't be able to change the front page, you won't be able to install backdoors and scripts, etc. Only problem is, you might find that most applications will want to write to one or two files. What you can do is set like a temporary directory to be a volume on the host, or you can use like a tempfs. So you can sort of poke holes in the read-only file system using volumes if you need to. Very similarly, you can set volumes to be read-only. Capabilities. So the Linux kernel defines a whole bunch of capabilities. Just people aware of capabilities? Some of you. So basically, capabilities are sort of groups of kernel calls you can make. So they govern like whether or not you can do things like change your ownership in files and so on. It used to be we had only root or non-root. You're either a user or you were a privileged user. And they tried to break it up a bit so you could have more fine-grained privileges. And that's where capabilities came in. By default, if you're in a Docker container, it gets a large set of privileges. But you can drop specific privileges. So here we've dropped the capability to set the set UID bit. But you can also drop all capabilities and just add back the ones you need. And the reason that's good for security, if an attacker breaks in, if you've reduced the number of kernel calls they can make, there's going to be less exploits, ways they can exploit the kernel. CPU shares. So if you're worried about people being able to, this is to address the concern that an attacker may be able to run a denial service by grabbing all the CPU on the host. However, you probably don't need to worry about this, because by default, all containers will get an equal share of CPU in the event of contention. So basically, if you use this relative weighting, so here we've got the CPU share argument, each container gets a default weighting of 1024. So if you do use CPU shares, you have to be aware of that. So what happens in this case, we've run one image, that one gets a default weighting of 1024, then we've run two other images that get a weighting of 512. What will happen in the event of contention is this first image will be able to use up to half the CPU, and these two will only get up to a quarter each. So it perhaps isn't entirely intuitive how it works. You need to be aware of that. And by default, you will get an equal share. So basically, don't touch that unless you know what you're doing. And there's also the completely fair scheduler you can use, which might be easier. However, much more important is memory limits, because a container can grab as much memory as it likes. And that's a very easy way to starve out other containers. Or if you have a memory leak, your container may just grow and starve out other containers. So you can quite easily just pass -m and set the maximum amount of memory it can use. Do be aware, if you have swap turned on, it will get an equal amount of swap. So this container has access to 512 megabytes of memory and 512 megabytes of swap. You can set swap separately. Nowadays, in newer versions of Docker, you can also set kernel memory. So that's like your stack pages and stuff. And that's interesting because that's one way to print a fork bomb. If you set the maximum amount of kernel memory and somebody runs a fork bomb inside a container, which basically tries to use up as many processes as it can to bring down the host. But if you set the kernel memory, it'll just run out of kernel memory and stop the container rather than bring down the host. Set UID and set GID binaries. So this goes back to that exploit I showed you before, where we created the set UID binary that gave me root on the host. And these are just binaries that run with elevated privileges. So you're a normal user, but if you run this binary, that runs as the root user. And there's a whole bunch of binaries like this. If you run this find command in a Debian container, you're going to get stuff like this, like a chown, which is, I guess, most people have used. But there's also stuff like chfn. Does anybody know what chfn does? Hands up if you know what chfn does. Anyone? OK, so, I mean, this is an application that's in your containers now. And if there was a vulnerability in it, it could be exploited by an attacker to gain root privileges, because it runs with a set UID bit. But nobody knows what it does, so it shouldn't really be there because you're not using it. What it actually does, if you're interested, is it's change full name. So if anybody used finger, it's like changes the data in that. But there's absolutely no reason for it to be there. OK, it's a very old Unix utility. You're very unlikely to find an exploit in it. but all the same, you don't need it, so why is it there? One thing you can do, if you're interested, is quite easily turn off the setuid bit. So if you just do chmod a-s, then that removes the setuid bit, so that binary will not be able to run as root. And if you use this find command, that'll find all the binaries and remove the setuid bit. And I bet your application will still run fine if you do that. Minimal images, so this is quite a good one as well. You're probably aware there's stuff like Debian container and the Ubuntu container. Ubuntu is probably about 80 megabytes, and the Alpine container is maybe about 4 or 5 megabytes. So there's like 70 odd megabytes there of software that you may not need. And that software can be potentially exploited by an attacker. So if you use less software, you have less attack surface. You can actually go even further. You don't even need Alpine Linux in some cases. If you're using Go or C or something, you may be able to compile a static binary and just use that. And that's really nice, but the problem is you will also lose all your debugging tools. So if you run a static binary in a container, you won't even be able to get a shell inside that container to debug things when things go wrong. So there is a trade-off to be made there. If you're interested in doing that in Go, you can have a look at that blog post, which shows you how to create a static binary inside a Go container. Security modules. What am I doing for time? Oh, sorry, I'll speed up a little bit. So there are security modules. If you're using Red Hat or CentOS, there's SE Linux, which was originally developed by the NSA. It's policy-based, mandatory access control. It is quite nice and quite powerful, but it's very annoying to use. Pain in the ass is the acronym there. I tried to define my own policy. I couldn't do it. It will limit the volumes you can use. And the first thing you'll notice if you turn it on and you try to run a container is that volumes don't work. And the reason is that you have to apply types and labels to everything. So basically, you have to use the chcon command to apply the correct label to my data volume here. Or there is also an easier way. You can boot #:z, and that'll do it for you. But that's what it does in the background. AppArmor is used by Debian and Ubuntu. If you're using Debian or Ubuntu, AppArmor will be on by default. So it's a little bit simpler, but it's not as fine-grained and as powerful as SE Linux. It's also a bit of an annoyance, but there is stuff like Bane that can help you create AppArmor profiles. Hardened kernels. So there's also stuff like GR security. You provide a hardened kernel, and you can turn on, and it'll do stuff like check memory and mark memory as being either data or control, so you can't write to run bits of memory, and it'll start things up in random places. And they're all very good security features, but they have a small effect on performance, and for that reason, they've never made it into the official Linux kernel. Also, you'll probably find that it'll lag slightly behind the latest version of the Linux kernel. But it's certainly something to look at if you're interested. Verify your images. This coming back to my point earlier about poisoned images. You want to know what you're running. You want to know where it came from. If you're using a Docker hub, official images are probably fine. Automated builds, so you get your automated images that are built on the Docker hub. Those are okay. I would suggest you go and look at the source code they're built from to make sure you're happy with them, but at least you can do that. You can check the Docker file and so on. There's also a bunch of images in the Docker hub that have just been pushed and don't have any associated Docker file or source code. Obviously, I'd be very suspect about using that because you have no idea what's in it. If you are worried and you have access to this source, you can, of course, just build the Docker images yourself. Docker content trust. So if you do export Docker content trust equal to 1, you turn on Docker content trust, and what that'll do is it'll set up keys. And it's a little bit like, you know, when you SSH into a new server, and it shows you that fingerprint and says, do you still want to connect? And you have to type yes before you can connect. It's the idea of trust and first use. And then every subsequent time you connect, it just connects immediately. Docker content trust is the same. So the first time you pull an image, it'll grab the key, but on subsequent requests, to the same repository, it will already have the key it was signed with, and we'll just download it. So it's a similar trust and first use concept. There's also secure digest. So if you create an image and push it to Hub, it'll give you a little SHA hash. Well, not a little SHA hash, a long SHA hash. You can use that to push and pull. The advantage of that is that that SHA hash is a hash of the content of the image. So even if that image, you then stored that image on a VM that's been compromised by someone, they will be unable to modify that image without you telling, because if you pull by that SHA hash again, it will verify the contents of the image against the hash. The problem with using digests is it's a little bit awkward to get the digest in the first place, and then you've got to get that digest onto your nodes, etc. Auditing. So this comes back to the idea of mutable infrastructure. You want to audit your images. So if you audit a single image, that may correspond to 100 running containers. And that's a bit different to the VM world, where VMs tended to, because you didn't have the, well, if you're running a golden image, that may work, but with VMs, you tended to have to audit each one separately. With containers, at least you can audit just the image offline, and then check that that image hasn't, the containers running that image haven't diverged from the image. Again, coming back to scanning tools, Scala, Twister, Docker security scanning. Finally, if we still have time, we okay? Yeah. Secrets. So I've got an image of a cat here. This cat was a cat in London, and he had a magnetic collar. So what he would do was he'd go around his neighbour's gardens, and he would find shiny objects, and they would get stuck to his collar, and he would take them back home. And at first, the owner felt sorry for him, but it quickly transpired that he was actually looking for these things and taking them back. And what he was finding was like the neighbours had hidden keys underneath plant pots and so on. So he was stealing like neighbours' car keys and backdoor keys and so on. Anyway. So how do you get your secrets into your containers? So the first idea is to bake it into the image, right? You can put it into your Docker file, like that guy's GitHub key. Hopefully, you're all immediately thinking, that's a bad idea. And it is, because anybody that has access to your image then has access to your secrets. So it's just not the way to do things. Environment variables. This one's quite popular. So a lot of people will pass in secrets by doing things like setting environment variables with your secret. And this works. And it's the way that 12-factor apps tells you to do things, if you've heard of 12-factor apps. And it's not bad, but it's not great either. And my problem is just that it can be seen in too many places. So, you know, if you do Docker inspect, you can see the environment variables. If you just run, it's no longer in linked containers. You know, and if you dump the environment, you get the environment variable. So say you're getting support on your database or something that you're running inside a container, and the guy asks for a dump of the environment, and you send him to that, suddenly you send all your secrets as well. So it's just too visible in environment variables for my taste. Yeah, they get included in reports. So the next thing you can try doing, and I would suggest this is probably the way you'll do it in the short term, is just to put your secrets into files and mount them. That works, but it is a bit icky. My main problem with putting secrets into files that get mounted is that files tend to end up checked into version control. And yeah, you don't want your secrets in version control. In the future, and hopefully the near future, the real way of doing this is going to be with secure key value stores. So if you're using Docker Swarm, you'll be glad to know that in Docker 1.3, they've actually got a solution for secrets. And you can look it up here. And so basically, you'll be able to do things like Docker secret create. And when you use that, it will place a file inside your container in a tempfs volume with the secrets you have access to. So that will be quite a nice solution when it lands. It will only be available in Swarm mode, though. Using Kubernetes, there is Kubernetes secrets that exist at the minute. However, that stores everything in etcd unencrypted, so do be aware of that if you're using Kubernetes currently. There's also Vault, and a lot of people are working on integrating Vault with various orchestration systems such as Mesos and Kubernetes. and Swarm. Vault is a secure key value store, and it's quite nice because it has things like leases on secrets. It makes sure everything's stored encrypted properly and has a whole bunch of features. Okay, so that's pretty much what I want to go through. The main point I want to make, though, is if you're using containers and you're using VMs, all you're doing is adding a level of isolation. You're not getting less secure by using containers. They just provide you with another layer of isolation and an extra set of tools for restricting attackers, etc. If you are concerned about container security, do use them with VMs in the ways I talked about. And also remember the principles of defense in depth and least privilege. Okay, thank you.
So thank you, Adrian. We have time for a few questions. If we have anyone in the room. No? Must have been a very thorough talk. That was one. One second.
Hey, great talk, very important topic, I guess. And my question is there a solution for appearing new vulnerabilities for existing Docker containers you use in production?
Yeah, that's a very good point. So when I was making that point about security scanning, the first thing you think about is like scanning your images before they go to production. But obviously, as new vulnerabilities turn up, then your containers that run in production at the minute will become vulnerable. But if you're using something like Docker security scanning, it maintains like a database of your containers, so it will tell you if a container becomes vulnerable, and it won't need to scan it again because it already has indexed all the files, if you like. So they have thought about that to some extent, but yeah, it's just something to think about. Does that answer your question? Yeah. Okay. But yeah, the point is you do also have to maintain, you do have to keep scanning the images in production as well as your offline images.
So, one more question.
Hi, great talk. Is there some system that you can recommend for automatically triggering downstream builds? For instance, you are basing your images on, I don't know, CentOS, Ubuntu, or something, yeah. And you might have several images, like you have CentOS with your company's tools, and then on top of that, an image of your application.
Yeah, right.
But so when CentOS gets updated, you need to update all the downstream builds and their dependencies and so on. Yeah. So is there some nice tool that you can recommend for that?
Yeah, so if you look at things like Docker Hub, you can actually turn that on. So at the minute, you can set your images to rebuild automatically, and you tell what parent image you're interested in, and if that image changes, it will trigger a rebuild. And I think there's also hooks. So you can set up your system whereby you get notified when an image changes, and then you'll have to set up your own CI/CD system to trigger the rebuild. But yeah, good question, and you can do it. But I'm not sure there's any great tools. You've kind of got to do it a little bit yourself with webhooks. Okay.
So any more questions? I think we have time for one more. Nope? Okay, thank you, Adrian. Thanks.